Earthquakes are going to occur at plate boundaries, mostly. We'll see they can occur off plate boundaries in some situations. On the left here, we have a subduction zone between oceanic crust and maybe the front edge of some oceanic crust here. So we have a volcanic island arc. There's going to be earthquake activity in the shallow crust right around the accretionary wedge and the volcanism associated with that subduction zone. As we dive down into the subduction zone, this cold slab of material is going to be pushing against the other plate, the opposite plate, and that friction and the deformation, that downgoing slab, is going to cause earthquake activity. If we mark those on a cross section, it marks what's called the Wadati-Benioff zone, so that going down into the subduction zone. That blue area is showing where normally the crust would be too hot for there to be earthquakes, but the downgoing slab is cold oceanic crust, and it is still brittle at that depth, where the rocks around it probably would deform ductily. You see where they squish around a little bit. The figure on the right is showing a mid-ocean ridge. So here is the magma rising up into the mid-ocean ridge. The pulling apart of those two plates at the divergent plate boundary is going to cause these tiny little normal faults in here. Whoops. These little normal faults in here, and that fault motion and the moving of the magma, it will cause that trace of the yellow dots on there at the divergent plate boundary. There's going to be offset along the mid-ocean ridge by one of these transform faults, so there'll be shallow strike slip motion offsetting the mid-ocean ridge, and so faults will occur as the friction builds up between the two segments of the mid-ocean ridge. Keep going up, there's going to be more motion along this segment of the mid-ocean ridge as it moves apart, and so faults are going to move and we'll have earthquakes there as well. Here's the earthquakes along the plate boundary, just going back a little bit. The red dots are earthquakes and the yellow are shallow earthquakes. So here, all around the Ring of Fire, we have earthquakes, a lot of red on there. Those are deeper earthquakes. The yellow represents some intermediate earthquakes. Wait, the red is shallow, right? Those are at the surface. So that would make a trace of the trench a little bit deeper. So intermediate would be the yellow, and then blue are the deeper earthquakes at the end of that Wadati-Benioff zone that is here. Sorry, I got a little tickle in my throat. So red is shallow, yellow, intermediate, and blue are the deeper earthquakes. So we'll go back again and look at that. Same thing is on this side of the Ring of Fire as well. Okay. All right. Move my head out of the way. Transform boundaries. So this is, you can see from space some of these faults. Here's a fault trace right through these glaciers. The San Andreas, this is in New Zealand. The San Andreas in California, we'll see that in another slide, is also a huge transform plate boundary. These earthquakes are going to be pretty shallow, and in this case, continental crust versus the transform faults that we do see at mid-ocean ridges. But these ones here, this is in continental crust. There's also the Anatolian fault in Turkey. Is also a big transform fault through continental crust. San Andreas. I mentioned earlier the 1906 earthquake in California in San Francisco. During that event, here's San Francisco, the city of San Francisco almost completely burned to the ground because of fires in the buildings. The San Andreas Fault separates the Pacific Plate from the North American Plate. It's a right lateral, so this plate, the North American Plate, moving to the right, and with the Pacific Plate moving up to the north. There's a bend in the plate here around LA, and this is the segment that is due for the big one, they say, whereas there has been some slippage around San Francisco, right around LA because of this bend in it. Maybe there's a point there that it can't get around, so it's building up lots of pressure along the San Andreas there around LA. Okay. Here is earthquake activity around Africa. This is a triple junction here, 1, 2, 3, and this is the East African Rift Valley. We've looked at it before with volcanism and plate tectonics, where this will eventually turn into a divergent plate boundary. Maybe seawater will flood this part of Africa, but there are faults there because of the extension, and so lots of little divergent motion or extension there, lots of little faults that have earthquakes along them all throughout that part of Africa. So this is the East African Rift Zone. There's also the Rio Grande Rift in New Mexico, not nearly as active, but an area where there are earthquakes. And then the Basin and Range, we looked at Utah earlier. The Basin and Range around the Great Salt Lake has lots of little earthquakes. In fact, just recently in the late or early spring of 2020, there was an earthquake around Salt Lake City. Here we've spread out some continental crust. Move my face out of the way. Turn it off. Starting at the leading edge here, this is the San Andreas Fault, and it's a near vertical fault plane. It's a right lateral strike slip fault. If you're standing on one side looking over, the other plate is moving to the right. Here is the East African Rift Valley, where we have a bunch of tiny little normal faults in here and earthquake activity. To the right here is a basin, and this is showing New Madrid, Missouri. So that's not along the plate boundary. That's in the middle of the North American plate, and it's an old sedimentary basin that has the weight of sediments on it and old faults under there that are reactivated from time to time. To the right here is the Himalayan mountains, and this is a convergent tectonics and really long reverse faults or thrust faults through the Himalayan mountains. There's also some near vertical motion in there in the center part of the Himalayan mountains, but these very long thrust faults on either side. It's kind of a pop-up structure is what they call it. Lots of fault activity and lots of earthquakes because of that collision in the Himalayan mountains. All right, intraplate earthquakes. Here is a zoom out on New Madrid. Like I was saying, it's in the middle of the North American plate. Zoom in, and we have Missouri, Illinois, Indiana, Kentucky, Tennessee, Arkansas. Where those states all kind of come together is along the Mississippi River. And earthquake activity does occur in that old basin there. In 1811, there was an earthquake that struck in, it was huge. It was a magnitude 7. It was a big surprise. The idea is maybe it was an ancient rift zone that failed, a failed rift. There aren't lots and lots of earthquakes that big that happened there. That's the biggest one that has happened in recorded history. During that event, though, it did reverse the flow of the Mississippi River. So pretty big moment in time in history for the United States.